Hi everyone, my name is Miss Riasso and I am going to walk you through some helpful hints for the MAT 152 lab on Unit 3, and it does have some review material. As always, we have our objectives listed here, and be sure to complete your work on this paper or insert your work into this document. Type labs will not receive any credit. Your answers need to be handwritten. Okay, other than your notes in your calculator or reaching out to your instructor, you should not be receiving help from other people, electronics, tutors, or apps. And again, we want you to do some of these questions in a specific way. So failure to complete the questions with the method as directed will result in no credit for those questions. Be sure to show all work and round as directed as well, and sentences should be grammatically correct and complete. So in this lab, we're going to be looking at boiling water. Traditionally, water boils at 212 degrees Fahrenheit or 100 degrees Celsius, and we want to see if that's actually true. So we're going to look at some pots of water from the Outer Banks all the way up to the Appalachians. Okay. So we have our boiling temperatures here, and then the number of pots here. So we're going to answer some of these questions. How many not bottles, sorry. How many pots were boiled in this study? So you'll calculate that from your table. And then we want to find our mean. And if we recall, when we have ranges of values, we can find the midpoint of those values and then use our frequencies to help us calculate the mean, right? You can go back to 3.2 if you need to see some extra help with that, but you're going to find your midpoints of all of these boiling temperatures. That'll go in L1 in your calculator. And then you'll list your frequencies in L2 and use the 1 var stats to calculate your mean. So you'll get that from the calculator and round it to 2 decimal places for right here. Again, make sure you're using units on your answers, please. Okay. For the remaining parts of the lab, we can assume our population standard deviation sigma of the boiling water is 3.75 degrees Fahrenheit. So that's going to be very important for the rest of our lab. So then we're going to go back to our central limit theorem and answer some questions, right? We can only use a z-test if our central limit theorem is true. So what are the conditions of that central limit theorem and does it apply here? Okay. Once we figure out if our central limit theorem applies, we can find our mu x bar, sigma x bar, and talk about the sampling distribution shape. Okay, very similar to what we did in the 7.581 lab for B and C here. So once we determine that, we can label the values, right? You should be labeling numbers on your curve here for your sampling distribution. And then we want to answer some questions. So we will recall that our book defines unusual as 2.5 or more standard deviations from the mean. So what was our value from number 2? We're going to write that on this blank. Based on our graph above, would that be unusual or not? And without performing the test, does it seem to indicate that our boiling point might not be what the traditional boiling point is? Okay. Now, we already know from the note up here that we want to make sure we're using our population standard deviation as 3.76. We can also use our sample size and sample mean from numbers 1 and 2 respectively, okay, for the rest of this lab. So we're going to perform some hypothesis testing. So our first hypothesis test, we want to test the claim here. This problem says different. Yours might say something else. So we're going to test the claim here. Keep in mind you want to set up your hypotheses. Typically, we'll have our null hypothesis and then our alternative hypothesis, and we'll state what those are going to be. And then on this problem, we are using the formula to show our work. So make sure you show your formula here and answer your question up here. Okay, z-scores and standardized test statistics should be 2 decimal places. Okay. On the next part, we want to find our p-value. So we have a graph here where you can sketch your claimed mean and your sample mean and shade the region according to those for the p-value. And what we are going to do is we are going to compute the p-value in quotes manually. So we're going to use a distribution function in the calculator. Remember, those are under second vars. We do not want to be using the test functions on this problem because we want to calculate it again in quotes manually. So be sure to show your work down here and answer your question here. P-value should be rounded to 4 decimal places. And then we'll conclude our test here. So since the p-value is either greater than or less than the level of significance, we want to make sure we put our number here. It'll either be 0.01, 0.05, sorry, 0.01, 0.05. Those are traditionally what we have. It'll depend on your problem, but it'll be up in the directions. And then are we rejecting the null hypothesis or are we failing to reject the null hypothesis? And given that, is our data statistically significant or not, right? So either our data are statistically significant or our data are not statistically significant. And then from our conclusion, what is our interpretation? Okay, at our level of significance, what are we seeing? Okay. We're then going to use our calculator to essentially do the same thing. Kind of think about it as double checking your answer above. So you should get the same results within rounding error of the previous problem. So here, what we are going to use is a test on our calculator. So remember, those are in stat test on your calculator. So you're going to choose a test from that list, and then you are going to write what your inputs are here, because we want to make sure that you're typing in the correct thing. Once you complete the test, it'll give you a standardized test statistic and a p-value, and you can make a conclusion on your test here. Note, you do not need to rewrite the interpretation or the hypothesis on this one. So then we're going to do another problem very similar. This one's in full on our calculator though. So we're going to set up our hypotheses and do the same steps essentially. Okay. Then we are going to look at a confidence interval. So we've done our hypothesis test. Now we're going to do a confidence interval. Again, we're going to be using our calculator here. And we can take our calculator function and our inputs to get our interval over here and then interpret our interval. Now what we are going to do next is see how our hypothesis test compares to our interval. So you're just going to restate your confidence interval here. And do we think that the conclusion is the same for number 4 and number 5? And we'll say if that is consistent with the confidence interval. So did you fail to reject or reject the null? And is that consistent with your confidence interval? And give an explanation why. And then this next part is very similar. So in our number 6 above, what did we conclude? And is that the same as the confidence interval? Once we have all of that information, we're going to write an article. It's going to be a short article, 3 to 5 sentences. And you're going to write this article as a professional. You should be defending your position on, is the mean boiling water in North Carolina really 212 degrees Fahrenheit? So you can assume your readers understand p-values, confidence intervals, and etc., but you should make sure you are being specific and using values and conclusions from the previous answers that you received in the lab. Okay, that is the last question on here. So if you do have questions please be sure to reach out to your instructor.